Yeah. So on the fundamental theorem of algebra, you'll notice they've given us a graph and it's identified the zeros. And we would like to know the number of real zeros, the turning points, would the degree be even or odd? What would the lead coefficient be? What would the possible equation be? And the end behavior. And I know at first this seems pretty daunting, but you can do this. It's pretty cool. So the first thing you do, real zeros means along the x-axis. So how many do we count? 3. So I'm going to write 3. And then I'm going to write exactly what they are. So this one is -2. This one is +3. And this one is 7. And then we want to know how many turning points are there? How many times does this graph change direction? 2. Yeah, I always look for the hills and the valleys, or if you were on a roller coaster, where would be the top where you go down? Where would you start your next going up? So there's 2 turning points. So is this an even or an odd degree? Well, it is odd, but if you're not sure, here's how the best way I know of. Always go back to this. I see lower left, upper right. So no matter what, I look at this, lower left, upper right. Up here, it says it's odd. Also, on this right here, you look here, and then it says my lead coefficient is positive. So I can go right here and do lead coefficient is positive. And I love that because so far, all I've really had to do is pay attention visually to the details. And that's why this unit can sometimes be easier than others because we're not relying on adding, subtracting, multiplying, and dividing, are we? Okay. Now, the possible equation. That's what comes next. Do you remember when we wrote this and we saw that these numbers here were the opposite of these numbers on our graph? And we even kept that in mind when we made this. The red one, the -6, 0 made a +6. The red -2 made a +2. And the red 3 made a -3. So we're going to keep that up here, which is why I wrote these. It is kind of long, so I'm going to go diagonal, but I should have 3 parentheses because I have 3 real zeros. So parenthesis x, x, x. And again, I'm just doing that on the diagonal because there's not a lot of space. And we want to do the opposite of what's on the graph, which is why I wrote these. What's the opposite of -2? Yep. The opposite of 3? Yes, I knew you'd knew that. And then the opposite of 7? Okay. Not too hard there. And it's not intended to be. This is about making connections of the fundamental theorem of algebra, how the graph can really tell us some things. Now, this last one is something we haven't done in a very long time, but it is in our notebook. End behavior description. That was this thing that we wrote. As x goes to some sort of infinity, the rule also goes to some sort of infinity. And then we describe the other end. But since we've already decided these ends match these ends, you can just copy right out of your notebook. That is totally fine with me. We just want you to get in the practice of writing it. So we're going to write, and I'm just reading from my notebook, as x approaches or goes to, and I have a positive infinity. Infinity is a sideways 8. F of x also goes to positive infinity. Yours might be backwards. It might say minus minus and plus plus on your notebook. Doesn't matter because they both are the same sentences. Okay. Right here, we saw this end right here is in the positive corner, isn't it? And that's why the positive are with those infinities. The other end is in negative, and that's why they're going to go with these negative infinities. So the structure is as x arrow infinity, f of x arrow infinity. The only thing that will ever change are these two signs based on where your end is. Okay? And you'll notice this one here is the positive, and this one here is the negative. You don't have to write them in if you don't want to, but if it helps you understand it, go for it. So to finish this one, we've just described the up end. Now we have to describe the downside end. And as x goes to negative infinity, f of x also goes to negative infinity.